Okay, sixth grade, this is the Chapter 10 review worksheet. Number 1 says, what must be included in an algebraic expression? This comes directly from your Chapter 10 key terms chart, which looks like this. This is also posted on Google Classroom. An algebraic expression is an expression that contains one or more variables and may also contain operation symbols like plus or minus. But to be an algebraic expression, it must have at least one variable, at least one unknown. So number 1 is B. Number 2, we have the product of x and 7 plus the quotient of z and 5. You should know that the product means multiplication. It's the answer to a multiplication problem. So if it's the product of x and 7, I'm multiplying x times 7. Now remember, whenever you write the product of x and 7, the coefficient should come first, which is the number you're multiplying by the variable. Right? So we write 7x. This is the product of x and 7. Coefficient first, and then the variable. So we have the product of x and 7 plus, so I put my addition symbol, plus the quotient. Quotient is the answer to a division problem. The quotient of z and 5 would be represented by z over 5. Z over 5 means z divided by 5, which would give us the quotient of z and 5. Okay, so I have 7x plus z over 5. Number 3, Roger's giving some candy to his 6 nephews. He wants to give each nephew the same amount of candy. So we're going to let x represent the total number of pieces of candy he gives to his nephews, and we're asked to write an expression to represent how many pieces of candy each nephew receives. Okay, so if x is the total amount of candy and he wants to give that candy out equally to his 6 nephews, that means we should divide by the 6 nephews. This will give us how many pieces of candy each nephew gets. For example, let's say that he has 30 pieces of candy. So we're going to let x represent 30. All right, let's say he has 30 pieces of candy and he wants to give each nephew the same amount of candy. We would take 30 and divide it by 6, and that would give us the answer to how many pieces of candy each nephew gets. 30 divided by 6 would be 5, and so each nephew would get 5 pieces of candy. But this right here is the expression that we need to represent this situation. Number 4, we need to write an algebraic expression to represent the phrase m less than 18. M less than 18. We need to write 18 minus m. This would be m less than 18. M less than 18. Here's what not to do. This is what not to do. And this is a common mistake. Students see m first and they write m. Then they see less than and they think, oh, that's subtraction, so I'm going to put minus. And then they see 18, so they'll write m minus 18. This right here is incorrect. This is 18 less than m. That's not what I'm asked to write. I'm asked to write m less than 18. All right, so this is represented by that phrase, 18 minus m. Number 5. Find the value of the expression below for when x is 5. So I'm asked to find the value, or I'm asked to evaluate the expression given that x is equal to negative 5. There are 3 steps whenever you are asked to evaluate something. Step 1, you set it up. You set it up by putting parentheses wherever you see a variable. So I'm going to copy that expression, 3x squared minus 4, except where the x is, I'm going to put parentheses. 3, parenthesis. I still need 2 as my exponent because that x is squared, and then I subtract 4. Okay, that's step 1. I've set it up. Step 2 is to plug in. I plug in what the variable is equal to. I'm told that x is 5, so wherever there's an x represented by the parentheses, I'm going to plug 5 into those parentheses. Okay, so I've set it up, I've plugged in. The last step is to evaluate. I'm going to evaluate by following the order of operations. Okay? The order of operations tells me that I do what's inside the parentheses first. Okay, I have 5 inside parentheses, and 5 is taken to an exponent, 2. 5 squared. That is the first thing that I must do. I cannot multiply 3 times 5 yet. I cannot subtract 4 yet. I have to take care of my exponents first. 5 squared means 5 times 5. 5 times 5 is 25. Now notice how I wrote the value of 5 squared inside the parentheses, because I still have to multiply this 3 times what 5 squared is equal to. So I write 3 parenthesis 25, since that's what 5 squared is. And I still have to subtract 4, so I bring it down to the next line. So now I have 3 parenthesis 25, which means 3 times 25 minus 4. Order of operations tells me that I must multiply before I can subtract. So I got to multiply 3 times 25, which is 75. I bring the minus 4 down, so I'm left with 75 minus 4, which is 71. And that is my answer. That's the value of this expression when x is 5. I set it up, I plug in, and I evaluate by following the order of operations. Number 6, I have 42 over w, which means 42 divided by w. Remember, this horizontal fraction bar right there means divided by. So I can read this as 42 divided by w. I'm asked what value for the variable w makes the value of the expression 6. So if I take 42 and divide by w, I should get 6. The question is, what value of w makes this equal 6? So basically I'm asking you, what is 42 divided by what gives me 6? 42 divided by what gives me 6? The answer would be 7, right? Because 7 times 6 would give you 42. Number 7, find the value of the expression below for x equals 8. So again, I'm asked to find the value, or evaluate. Whenever you evaluate, you're following these 3 steps right here. You set up, you plug in, you evaluate by following the order of operations. So I copy this expression. Every time I see a variable, I use parentheses. So I have x squared plus 3 times 2x plus 4. I've set it up. I copied, put parentheses in place of the variable. Then I plug in 8 for x. So every time I have an x, I'll put 8. 8. I've plugged in. Now step 3, I evaluate by following the order of operations. I take care of what's inside the parentheses first, right? I follow order of operations, which we use the acronym PEMDAS. Please excuse my dear Aunt Sally. I do what's inside the parentheses. I take care of exponents. I multiply and divide from left to right. I add and subtract from left to right. So let's do what's inside the parentheses. I have 8 squared plus 3 times 2 times 8 is 16. Then I have plus 4. I still have parentheses, so I bring everything else down. 8 squared plus 3 times 16 plus 4 is 20. So now I have 8 squared plus 3 times 20. 3 times 20 is 60. Now I have 8 squared, which is 64, plus 30. 64 plus 30 is 94. Sorry, this is 64 plus 60. I knew I got something in. 8 squared plus 60. 8 squared, 64 plus 60. 64 plus 60 is 124. Sorry about that. It's always good to go back and double check your work. Number 8. We're told the height of horses is measured in hands. To find the height of a horse in inches, use the expression 6h. This is the expression we're using, 6h, where h is the number of hands. Henry has a horse that is 12 hands tall. It's 12 hands tall. How tall is Henry's horse in inches? So if I use this expression, I plug in 12 for the hands, 6 times the number of hands, that will give me the number of inches. 6 times 12 is 72, so the horse is 72 inches. On the back side, number 9, again I'm asked to find the value, which means evaluate. I'll use those 3 steps to evaluate. the expression below for x equals 9 and y equals 2. So now I just simply have two different variables, but I'm told what those variables are equal to. Step 1, set it up. 5 plus x plus 3 over y. I've set it up. Now I plug in. I plug in 9 for x, so 9 goes there. I plug in 2 for y. Then I follow order of operations. Okay, so 5 plus, on the top I have 9 plus 3, which is 12. And on the bottom I have 2. So I have 5 plus 12 over 2. 12 over 2 means 12 divided by 2. 12 divided by 2 would be 6. So 5 plus 6 is 11. Number 10, which property justifies the fact that 12 times y plus 4, that's how I read this, it's 12 times y plus 4, is equivalent to means equals, which property justifies the fact that 12 times y plus 4 is equivalent to or equals to 12y plus 48? That would be the distributive property. If I have 12 times y plus 4, I would distribute by showing the rainbow. I have 12 times y plus 12 times 4. So that would give me 12 times y is 12y. 12 times 4 is 48. Okay. This comes from our properties chart. Looks like this. The properties chart, also posted on Google Classroom. This right here explains the distributive property. Okay. Number 11, I simplified the following expression. Here I have 6x plus 4 times 3x minus 2 minus 5x. Whenever I see this right here, a number written right next to a set of parentheses, that tells me I must multiply. Okay? Since there are two terms inside the parentheses, I need to distribute this 4 to both terms inside the parentheses. Okay, so I must do that first. I bring down this 6x because I can't do anything with it until after I distribute that 4. Then I have 4 plus 4 times 3x. I put plus 4 since this is a positive 4. It's a positive 4 that I'm distributing. So plus 4.3x, which means times. Then I am subtracting inside the parentheses, so I subtract right here. I draw a rainbow from 4 to 2. I multiply 4 times 2. Okay. Now I do not draw the rainbow from 4 to 5x because 5x is outside the parentheses. If a term is outside of the parentheses, it does not get distributed to. So all I do is add this on to the end. I put minus 5x since the minus sign is in front of the 5x. So then now this is my expression. I go through and I multiply. I still have 6x plus 4 times 3x is 12x. Because you multiply 4 times 3, which would be 12, and you keep the variable and the exponent, which is 1, minus 4 times 2, which is 8, and then I add on minus 5x. So now I combine like terms. I have x to the first terms. 6x is a like term to 12x, which is a like term to minus 5x. Those all have variable x and exponent 1. That's what makes them like terms, and I'm showing that they're like terms by putting them in boxes. So now I add their coefficients. 6x plus 12x would be 18x. 18x minus 5x would be 13x. And all I'm left with is this minus 8, which is a constant. So I add that to my simplified expression. Since there are no other constants, I can combine that with. So my final answer would be 13x minus 8. Number 12, similar problem. Here I have 10 right next to a set of parentheses, which means I'm multiplying 10 times x plus 2, so I'll need to distribute. I show my rainbow, 10 times x plus 10 times 2, 10 times x, 10 times 2. I distributed the 10 to x and 2. I add on the 5x and I add on the 4. Since those terms are outside the parentheses, I do not distribute the 10 to those terms. I simply add them on at the end. Now I go through and multiply. 10 times x is 10x, plus 10 times 2 is 20, plus 5x, plus 4. Now I can combine like terms. I have x to the first terms, 10x, plus 5x. They have the same variable x, same exponent 1. So 10x plus 5x is 15x. And then I add my constants. I have a constant positive 20 and a constant positive 4. If I add those together, 20 plus 4 is 24. So I put plus 24 since this 24 is positive, right? 20 plus 4 is 24, positive 24. So this is my simplified expression, 15x plus 24. Number 13, I simplify the following expression. I look for my highest exponent. My highest exponent is 1. Okay, but here I have two different variables. I have x and y variables. So first, let's combine the x variables. I have plus 3x, and I have plus x. Now remember, the coefficient right there, when it's not written, if the coefficient is not written, it is 1. So this is actually 1x. 3x plus 1x would be 4x. Okay, now let's combine my y terms. I have 7y, which I'll put in a circle, and I have minus y. Again, there is an invisible 1 right there because the coefficient is actually negative 1 or minus 1. So 7y minus y, or 7y minus 1y would be 6y. So I put plus 6y since it's a positive 6y. And this is my simplified expression. I cannot combine these because they're not like terms. This has an x on it, this has a y. So they're unlike terms. So this right here is simplified. Number 14, I have a rectangle with length 2x plus 8 and a width of 3x plus 6. It says write a simplified expression that shows the perimeter of the rectangle. So if I have a rectangle right here, and the length is 2x plus 8 and the width is 3x plus 6, I need to write an expression that shows the perimeter. The perimeter is the distance around the rectangle. So I know if this side is 2x plus 8, then this side is also 2x plus 8, because these sides of the rectangle are equal to one another. So same thing on these sides. If 3x plus 6 is this side is equal to this side. They're the same length. Okay, so I know these sides are 3x plus 6, and these sides are 2x plus 8. Now there are a couple different ways to do this. I'm going to show you the distributive property way. If I have 2x plus 8, that means I have 2x plus 8s. Right, there are two of them, 1, 2. I have 2x plus 8s. And I also have 3x plus 6s. Right, here's one 3x plus 6. Here's another 3x plus 6. So I can say I have 2 of them. Okay, so I have this expression now. Now I can simplify by using the distributive property. 2 times 2x plus 2 times 8 plus 2 times 3x plus 2 times 6. I distribute the 2 to both these terms, since the 2 is right next to these parentheses, and I distribute this 2 to 3x and 6. Then I go through and multiply. 2 times 2x is 4x, plus 2 times 8 is 16, plus 2 times 3x is 6x, plus 2 times 6 is 12. Now I combine like terms. I have x to the first terms, 4x and 6x, which would give me 10x. And I have constant terms, 16 and 12. 16 plus 12 is 28. So this expression, 10x plus 28, would give me the perimeter of this rectangle. Finally, number 15, answer the following questions about the expression below. I have 9x to the fourth minus 2x squared plus x plus 125. Question A says, how many terms are there? There are 4 terms, right? They're separated by the plus and minus signs. Here's term 1, here's term 2, here's term 3, here's term 4. 4 terms. What is the coefficient of x? So right here is what I'm looking at. The coefficient, remember, is the number before the letter. So what number is before the variable? As you can see, there is no number there. So whenever there's no number before the variable, the coefficient is 1. C, what is the constant term? Remember the constant term, according to our key terms chart, numbers that are, a value that does not change. They have no variables. Okay, so we're looking for a number that has no variable. This has a variable x, this has a variable x, this has a variable x. 125 has no variable. So my constant term is 125, and I know it's a positive 125 because it says plus 125, which makes it
a positive 125. And I don't need to write the plus because if it's a positive number, you don't put plus, you just write the number. And letter D, what is the highest exponent? The highest exponent here is 4. Okay, so this is the Chapter 10 6th grade review worksheet.